Okay, so now we're going to move on to the Krebs cycle, which is the first part, or the first main part, of cellular respiration. So like we talked about with glycolysis, when there is oxygen, so in the presence of oxygen, pyruvic acid, the pyruvic acid that is produced in glycolysis passes to a second stage of cellular respiration known as the Krebs cycle. During the Krebs cycle, pyruvic acid is broken down into carbon dioxide in a series of energy-extracting reactions. Because citric acid is the first compound formed in this series of reactions, the Krebs cycle is also known as the citric acid cycle. So we're going to talk about citric acid production, and then we're going to talk about energy extraction. So the Krebs cycle begins with pyruvic acid produced by glycolysis, so that pyruvic acid produced by glycolysis passes through the two membranes of the mitochondrion and into the matrix. So if you don't remember what a mitochondrion is, or the structure of it, you need to go back and look at your notes. The matrix is the innermost compartment of the mitochondrion and the site of where Krebs cycle reactions. Once in the matrix, one carbon atom from pyruvic acid becomes part of a molecule of carbon dioxide, which is eventually released into the air. So remember, the pyruvic acid is 3 carbon molecules. So one right off the bat, once it comes into the matrix, one of those carbons is kicked out as carbon dioxide, released into the air. The other 2 carbon atoms from the pyruvic acid rearrange and form acetic acid, which is joined by a compound called coenzyme A. Basically, the resulting molecule is known as acetyl coenzyme A. You don't need to know what the acetyl part is made up of, although for those who want to know, it's made up of 2 carbon atoms, 1 oxygen atom, and 3 hydrogen. So basically, as the Krebs cycle begins, acetyl coenzyme A adds the 2 carbon acetyl group to a 4 carbon molecule that's already present in the cycle, producing a wonderful 6 carbon molecule called citric acid. So here's the pyruvate. Keep in mind, guys, you get a total of 2 pyruvate acids from glycolysis. This is going to take us through the process of 1 pyruvic acid going through the Krebs cycle. So the pyruvic acid is broken down, carbon dioxide is given off, and we get the coenzyme A, which bonds to the 2 carbon molecule, and then it basically enters the Krebs cycle. So keep in mind the Krebs cycle produces energy-carrying molecules. As the cycle continues, so here's, we were just over here at like the pre-stage. So here's our citric acid that we just formed. So as the cycle continues, citric acid is broken down into a 4 carbon molecule, more carbon dioxide is released, and electrons are transferred to energy carriers or electron carriers. First, you're going to look at this beautiful 6 carbon molecule. In citric acid, so right there. 1 carbon is removed, and then another releasing 2 molecules of carbon dioxide. So we lose carbon dioxide here, and we lose carbon dioxide there, leaving us with a 4 carbon molecule right here. Because the 4 carbon molecule produced in this step number 5 and 6, because it's a 4 carbon molecule produced in this last step, is the same molecule that originally accepts back in this picture. It's the original. I don't have the one big graph picture that you guys have in your book, so you can use your book. Excuse me. Because the 4 carbon molecule produced in the last step is the same molecule that accepts the acetyl coenzyme A in the beginning, in the first step, The molecule needed to start the reaction of the cycle remains with every turn, is remade with every turn. So now we're going to look at the electron carriers, known as NAD and FAD2, or FAD. So at 5 places throughout the Krebs cycle, the electron carriers accept a pair of high-energy electrons changing NAD plus to NADH, and FAD over here, or FAD2 plus to FADH2. Basically, all you need to know is FAD and FADH are molecules similar to NAD and NADH respectively. So what happens to each of these Krebs cycle products? Carbon dioxide. So the products are carbon dioxide, ATP, and electron carriers. The carbon dioxide is not useful to the cell and is pretty much expelled every time you exhale, hence why we breathe out carbon dioxide. The ATP molecules are very useful because we love energy and become immediately available to power cellular activities. As for those wonderful carrier molecules, in the presence of oxygen, the electrons they hold are used to generate huge amounts of ATP. So that is pretty much the Krebs cycle. So again, NADH is made, intermediate molecules with coenzyme A enters the Krebs cycle. We talked about this, citric acid. Okay, so this is everything that we just talked about. And so if you have any questions, refer back to your book. But hopefully it made sense. This is a lot here, so if you just write this down, you're going to get very confused. But we essentially walked around what we needed to know.